Okay. Thank you very much. So I will talk about our cloud-free Sentinel-2 mosaic generation over Norway, where we are utilizing MAJA and WASP. My name is Ferdinand Klingberg. I have with me my colleague Carl William. The two maybe mainly working with this in Norwegian Mapping Authority. So today's outline will be this introduction and how we are utilizing MAJA and WASP. We also have a bit like a documentation, and we showcase the data we are working with. And I would like to talk a bit about the current challenges and possible the next steps we will look into. And after that, show some use cases and applications. And I want to mention that Norwegian Space Agency is partly funding this project, so we are very grateful for that. So a quick introduction. You can maybe ask yourself, like, why are we creating cloud-free mosaics? And the one reason being that we want to create products available for the main audience in Norway. Either you are very beginner or you are the expert. And as simple as RGB image that you can open in your PC without even using a GIS tool, or for the one that needs to calculate and do raster calculation on all the 10 bands we are working with. The other reason is, as I think was hopefully had working over here, changing through the different times from 2018 to 2024, we will have then the ease of seeing seasonal and both also annual change for time. And then also, why are we utilizing MAJA and WASP? In the very beginning, when we started with this, we did draw cloud and cloud shadow by hand, and it is very time consuming. I give you that. We see that we want to create similar products each year, and with such solution we can manage to do that. We tried in the very beginning the Sentinel-2 global mosaic, and it didn't work at all, basically for our area. So luckily in 2020, MAJA turned open source, and WASP already turned open source in 2019. So we was looking about what France did for their production, and wanted to do this over Norway. So we have a bit different targets and how we're utilizing MAJA and WASP. We do make some quick level 3 production. So products between June, July, and August are quickly distributed on our geonorge.no, where we are storing different solutions from the Norwegian Mapping Authority. We don't do any correction, but we do such correction on our master mosaic. That's the extent for the period of June and August. So we have one clean product each year. And that will take some more time to produce and for correct and etc. All this is done on one processing server. We have one test server as well for updates of MAJA and WASP, and also 2 file servers. The production of MAJA is done. We activate the cams, but we also work it with a bit like a modified DM, such that we replace the elevation model over Norway with Copernicus DM, for instance. So we are a bit like changing pixels of the Copernicus DM. And for the production, we do 2 tiles at the time at the one file server. So in total, 4 scenes are produced at the same time. And when it comes to the WASP production, we do 1 tile at the one file server. It's a small team. It is me and William that produce this mosaic. So we are neither like time critical delivery or anything like that. So we have time to update MAJA and update WASP when needed, and we can wait 5 days for cams data being available. Is okay. So just to give you a bit more like a flow chart of the process here. The process starts with the downloading camps for the current days we are processing. We have worked quite hard this year to make the process rather automated with a Python script. So we are in a parallel processing, downloading, and then also processing this MAJA on 4 processes at the same time. After that, when all the scenes for our target season is produced, we can then generate the JSON files that is needed for the WASP production. And then we can also give them a specific date range that we are working with. So I mentioned we are delivery in June, July, and July, August. But also for maybe future, we want to see a bit like if we can also produce a seasonal production. And then we can then process all this JSON file that we produced with the WASP processor. And the reason we do different setup for this is that in many times we notice that the process of the WASP needs some correction, and then we can directly correct this JSON file and removing the one that is giving us a problem. Okay, yes, we are a small team. It's important with documentation, so we have already set that up for material for MKDocs. As of now, it is in Norwegian. If I one day deliver this Python scripts, then everything will be translated to English as well. The Python script is already in English. This will hopefully was a video almost. It will go through all the dates we are working with. So over in Northern Norway, it is very static. But what my main target with this GIF was that we have a lot of scenes, but it's not given that you will get a good result having a lot of scenes, because mostly of them are with clouds and or, as we see here, a lot of snow. And that when we have looped through all that scenes, we have a production of this like over the same area. So this is the scenes we are working with, and we can see some patches of snow is left behind, but at least cloud-free. But that's it's not always the case. We have some challenges, and one of them being that the glaciers, clouds over glaciers, is we get that every year. Also, we have seems like patches of snow is also not detected year by year, and also we have every now and then some clouds that are like completely covering our level 3A product. I hope it will be nice to discuss or share out these ideas we will like to further investigate to see if we can look a bit more on this snow cover detection algorithm in MAJA, and maybe the let it snow or like algorithm could be like a further step to look into, or almost like a question to the audience here, like is it any settings we should tune to improve MAJA cloud detection over Norway? Yeah, with that said, so just to showcase, this is glaciated area over Norway. Maybe not easy to see that it contains some clouds. On simple RGB, it is maybe okay, but if you are the one expert user and you want to utilize all the bands, you will notice there are clouds in the image there quite easily if you combine it with the different bands. So jumping ahead, I want to showcase that some use cases and applications we do in Norwegian Mapping Authority. We're not the main user of those mosaic. We produce them mostly for other people, but we do some research and try to see if they can be useful. And in that case, mostly useful for detecting our needs for doing accurate update of our maps. So we've been looking into these 4 use cases, one of them being to update 1 to 50,000 topographical land cover data, where we are utilizing this OTBF TensorFlow module. We also looked at OBA with the tree classes classification with the EOTA2, and also road detection, where we are combining this mosaic reproduce and the Copernicus very high resolution satellite data. Again, also with the machine learning. And also very pleased to see the super resolution that is already working very well on MAJA 2 scenes with a pre-trained model in the frame of Evil and Horizon Europe. So quickly showing some results of that. We have, you don't see it now, but it was looping GIF over here before, but it showcased our land classification, comparing it to the reference scene. I'll quickly jump because we don't see it. Otherwise, it can't be activated if you hold your mouse over this scene. No, it doesn't seem. No, then we go further ahead. So making one model, it's quite easy to generate it for the whole Norway with one of the mosaic we are making. So this production, in fact, just took 3 hours. Also, we have just started to see if this with the time series is useful and has any potential. And then in this IOTA2 framework with the OBA, we have then used a full stack of 65 scenes of MAJA, and then did the tree classification of spine prune and the deciduous forest. And it works rather well when we compare it to older reference data. So, but I don't have any number to show you here, but visual, and this is something we will look more into the future. And also the very same scene with just we want to use less data, but of course they have been already processed before with the WASP processor. So this is then with 4 season mosaics instead. So they are a bit different, but it's also a way to go. But also we need to further investigate that. One example is the real potential, at least for this mosaic, and also in the combination of the high resolution satellite data we have access to through the Copernicus program, and that is the very high resolution satellite data we are looking into here. This example showcases the road we have in the Norwegian mapping database. Red one being normal roads, and the blue one being the roads that are related to agriculture, tractor roads, etc. And I hope you see that there are some roads that are missing. And simply by doing this machine learning, we can try to detect them and then do this overlay, and we can find potential missing roads. It doesn't say that we will just use the product here, but it will then, we will identify the area that needs to be updated and can be drawn by hand and give them a lower quality class. So at least it is updated in the map for the end user, but in the future when we are targeting, let's say, aerial images, we know where to go for update immediately. Yeah, just to showcase that. And also quickly look at this super resolution. That is a very easy tool to use with the already processed MAJA scenes. Yes, I think that was all. And if it is any question, you can just take them now or contact me.